A best fit line is a straight line that summarizes the overall pattern in a scatter plot. You start with paired data, an x value and a y value, and you plot each pair as a point. If the points roughly follow a straight trend, a line can describe how y changes as x changes, even though the points do not land perfectly on that line. The key question is what best means. It does not mean the line that looks nicest. For any proposed line, you can measure how far each point is from the line vertically. That vertical difference is called a residual. Some points fall above the line, some below. If you simply added the residuals, positives and negatives would cancel. To avoid that, we square each residual and then add them up. The best fit line is the one that makes this total squared error as small as possible. This method is called least squares. The equation of the best fit line is y hat equals b0 plus b1x. Y hat means the predicted value of y. b1 is the slope and b0 is the intercept. The slope tells you how much y is predicted to change when x increases by 1 unit. The intercept is the predicted y value when x equals 0. To find the line by hand, there is a clear procedure. First, compute the mean of the x values and the mean of the y values. The best fit line always passes through the point made by those two means. Next, compute the slope. The slope is found by taking each x value minus the mean of x, each y value minus the mean of y, multiplying those deviations together, adding them up, and then dividing by the sum of the squared x deviations. Once you have the slope, find the intercept by taking the mean of y minus the slope times the mean of x. Once you have the equation, drawing the line is simple. Choose two x values, often the smallest and largest in the data. Plug them into the equation to get two predicted y values. Plot those 2 points and draw the straight line through them. That is the best fit line. Interpreting the line is just as important as drawing it. If the slope is positive, y tends to increase as x increases. If the slope is negative, y tends to decrease as x increases. The size of the slope tells you how strong that change is per unit of x. The intercept only has a real meaning if x equals 0 makes sense in context. If x equals 0 is unrealistic, the intercept is still mathematically necessary, but it should not be overinterpreted. Finally, always check whether the line is reasonable. Look at the residuals. If they scatter randomly around 0, the line is doing a good job. If you see curves or patterns, a straight line may not be appropriate. A best fit line is a powerful summary, but it is a model, not the data itself.